This talk is titled Monitoring Legacy Infrastructure with Elixir and OTP. Who am I? My name is Jeff Gillis. I'm an infrastructure engineer at Optoro, based out of Washington, D.C. At Optoro, we help large retail companies manage their returns and excess inventory. You can find my GitHub account at jgillis01. So the goal of this talk is to demonstrate the creation of a simple application for monitoring infrastructure with Elixir and OTP. And hopefully by the end of the talk, I could show you how to export those metrics so we could be more proactive about establishing patterns about issues within our infrastructure. So a little bit of background. At Optoro, we're adopting a microservices architecture, and it looks something like this from about 10,000 feet. So we're deploying containers into a container group, and through service discovery, those containers automatically hook up to a metrics pipeline. They automatically hook up to a logging pipeline, and a load balancer automatically sees those so it can route traffic to them. But like most companies adopting a microservices architecture, we still have a legacy monolithic application. Because it's legacy, it has limited metrics reporting from that application. And we also have lots of background workers running the same legacy code. And these background workers power a lot of our warehouse operations and our marketplace integrations. So how do we troubleshoot these issues when they arise in our legacy infrastructure? Well, first of all, it's a manual process. We have to SSH in to that instance and execute commands from the command line to see what's going on. Some of the questions we might ask ourselves are, how many operating system processes are running? What connections do these services make to other services? This is important. If these services are getting overloaded, we need to figure out what's causing that. And does a process consume too many resources on that instance, right? And how long has that process been running? We have a reasonable expectation of how long, say, our background worker processes should be running. So typical commands that we might run to figure out what kind of processes are running is PS, and then we could filter that to find the process that we're interested in. We also could figure out the start time of a process by using the stat command and passing in the PID. We could find connections for a given process by using LSOF and filtering that for the PID. And we can also find generic resource consumption for a given PID by using PS. This will give us our CPU utilization as well as memory utilization from an operating system perspective. So how do we make this easier? We have to log into all these instances and kind of figure out what's going on. It'd be nice if we could bring this together in a centralized view to troubleshoot these issues. And it would be also nice to be able to terminate problem processes when we identify them. What are our options? Well, we already have an SSH connection to the box, so we could use that. And maybe we can use Elixir as well to help us with this. So why would we want to use SSH? Well, on top of already having that vector to use, you might be at risk. It might be a risk to modify production infrastructure, right? You don't want to touch it. Some people get into that position. The target application might be consuming all the resources available on that instance. So putting an agent on that instance might not work because it's already starved for resources. And you also may have security issues that prevent you from exposing process information through other means like HTTP, something like that. So why would we want to use Elixir for this? Well, resource usage with Elixir applications is actually pretty good compared to other languages. Of course, we get concurrency and fault tolerance with Elixir and Erlang. And Erlang already has built-in SSH server client and server libraries. So using Elixir and SSH, there's already a nice library out there that kind of wraps these Erlang libraries. And you can find that at rubincaro/SSHEX. So how might we use this? Well, after we add it to our mixed dependencies, we can call connect on the SSHEX module and pass in a keyword list of our options. And then we could use that process that's returned to send the command to our instance. This is going to return a new line delimited string, and we could split on that, filter out any empty strings, and trim it up to make it look nice. We can also send a command to that same process to find the start time of a given PID. So some things to notice here is that we created a connection to via SSH to a server, and we set commands to a process representing that SSH connection in Elixir. This connection is persistent. I don't have to close it and reopen this connection every time I need to send down a command. And subsequent commands are sent through the same connection. So we've got a PID now, but it would be nice to store that PID for later use. And an easy way to do that is to wrap it in a GenServer process. So here I've created a GenServer module, and it's just going to take our list of options that SSH accepts, and in our init callback, we're going to pass that through to the SSHEX connect function. Now this connect function already returns an OK PID callback or response, which is what the GenServer expects. We can also decorate this module with commands to help us send commands to the SSH connection. So you can see in our handle call callback, we're passing the command straight to the connection that we've stored in its state, and we're replying with that result and storing that connection for later use. Let's see how we can use this. So we're going to create our keyword list of options again. And then we're going to call start link on our new module. And then we're going to send to that process a command. And it works, just like we expected it to with the SSHEX library. So some things to notice here, we created a GenServer wrapper around the SSH connection. And this allows us to dispatch the commands to that SSH process and store it for later. We can also add decoration functions to help us parse the command results and make that SSH connection easier to use. But have we really gained anything? I still have to manage a process PID, right? How do we manage this instance to PID mapping? It would be really nice if I could just use the name of the instance that I want to send the command to. And what happens if that process dies? If I try to send a command to a process that's not alive anymore, it's going to blow up. So that's where another OTP behavior comes in, and it's called the registry. According to the documentation, registry is a local, decentralized, and scalable key value process storage. It allows developers to look up one or more processes with a given key. If the registry has unique keys, a key points to 0 or 1 processes. In addition to that, each entry in the registry is associated with the process that has registered the key. If a process crashes, the key associated to that process are automatically removed. So that seems to handle the case where if a process dies, the registry is going to monitor that process. When it sees that it goes down, it's going to remove it from the registry. So how do we use the registry? Well, it's actually pretty simple. We call start link on registry. We tell it what kind of registry that we want. In this instance, we're going to create a unique key registry, and we're going to give it a name, instance registry. Then we're going to try to register against that registry a key. And in this case, we're going to give it an instance name, and we're going to give it a value, hello. We can do a lookup against that registry for that key to get back the value associated with it and the process that registered that key. If we try to register another value against that key, we get an error because it's a unique registry. It tells us that it's already been started, and it gives us the process that registered the initial key. So the documentation recommends that to use a registry, we add it to a supervision tree. So you can create your mix application with --sup to add a supervision tree. And so you can see here we've added this registry to our children's list for our supervisor, and we're going to name it app supervisor. And we can verify that it's being started. So we're going to call supervisor.whichChildren, and we're going to pass in the name of our supervisor. And as you can see, our instance registry has been started with our application. So now we need to go back and modify our instance server. And another neat feature of the registry is that we can register name processes using via tuple. So if you can see at the bottom, I've created a name via registry private function. I'm passing in the instance name, and I'm returning the tuple that's going to be used to register that name process. In the start link, I'm extracting the instance name from the keyword list and passing it into our function. And then I'm using the result, that via tuple, to name our process. Similarly, when we execute a command, we can reconstruct the name of that process and use it to call that process. So let's see how this works. So let's say we have 10 servers that we want to create SSH connections to. I'm going to create a keyword list for each one of those. And for each one of those, I'm going to create that SSH connection with our new instance server. And now instead of using the PID, I can use the instance name to execute that command. So some things to notice here is that we registered a process with a registry. And because we're using name processes, we no longer have to worry about the PID. We can reference these processes by the instance name. But what happens if that process fails? Well, we already know that if the process fails, it's going to get removed from that registry. But it would be also nice if we could actually restart that process. And that's where supervisors come in. So if we look at our requirements, we need to restart a process if that connection fails. But these processes need to be added at runtime, not when the application starts. So fortunately, since Elixir 1.6, we have the use of the dynamic supervisor, which was created for this use case. And in order to use that, we can add it to our supervision tree. So you can see here, I'm adding the dynamic supervisor, and I'm giving it a name, instance supervisor. Next, we can create a module to use that. And we're going to create a new function called add instance connection that accepts those same options. And instead of calling the server.start link directly, we're going to use our dynamic supervisor to start those service processes. We're also going to delegate a command, execute command, to that server. So let's see how we use that. So we still have our 10 servers. We're going to create our options list. And then instead of calling the server.start link, we're going to use our new process monitor. Now we can execute a command against worker 10, and we get our results back. So now we're going to get the process ID for that one, and we're going to kill it. We're going to execute a command again against worker 10, and hey, look at that, it got restarted. So what happened here? We found the process, we killed that process, it got removed from the registry because the registry saw that it went down. Our supervisor saw that that process was down and restarted it, and when it got restarted, it got added back to the registry. But now that we have this, how do other processes use these connections? We know in Elixir that processes communicate by sending messages. But to which processes do we send these messages? We may not know that at runtime. And we want to notify any interested processes when these SSH connections are ready. You know, we're using network connections here, so these processes may take a little time to get established. Fortunately, registry can also provide publish and subscribe behavior. In order to do that, we're going to create a duplicate registry. And we're going to add it to our supervision tree, and we're going to give it the name notifier. We're also going to create a couple of helper functions to help us use this new registry. So we're going to create a subscribe function. We're going to pass in a channel parameter in the PID, and it's really just the key that we're going to associate in that registry. And the value would be the PID. Next, we're going to create a notify function. We're going to pass in that key, the channel, and a payload. And for each key in that registry, we're going to dispatch a command. We're going to extract the PID from each entry, and we're going to send a message to that PID. It's going to be a broadcast message with the payload. This function is actually lifted directly from the documentation for the registry. You can find that online. So next we need to update our instance server. What we're going to do is we're going to import our notify function from our utils module that we just created. We're going to create our SSH connection in our init callback, and right after we do so, we're going to notify that that connection is ready, and our payload is going to be our instance name. So let's see how this might work. So what we're going to do is we're going to spawn a function, and we're going to immediately subscribe to the connection ready key in that registry, and then we're going to wait to receive a broadcast message with that payload. And when we do, we're going to output to the screen that we received that message. And once we receive that message, we're going to actually execute a command against that SSH connection. And we're going to output the result to the screen. Next, we're going to create our keyword list. And then we're going to add that instance connection. So as you can see here, we received that broadcast from the PubSub registry that we created, and we immediately executed a command against the ready SSH connection. So thus far, we were able to create a GenServer process to wrap our SSH connection. We made these named processes and registered them with our registry. We created some functionality to supervise and restart them if that SSH connection goes down. And we also created a way to notify other processes when these SSH connections are ready. But you know, it would be nice to visualize these. In order to do that, we can create a Phoenix application and pull in our library. So what we can do is we can go to the dependencies in our Phoenix library, in our Phoenix application, and pull in our library. Next, we can create an instance monitor module, and we can import our utilities. And inside of that, in our init callback, we can subscribe to that connection ready broadcast. Next, in our handle info callback, we can create a process that will actually send a command to the SSH connection for what we're interested in and parse the results. From here, it's pretty trivial to create your controller and views to display this information. So some things to note. Once you have this information, you can call process.sendAfter to periodically refresh that information to get the latest from that instance. You can register your GenServer process with a duplicate key registry to track instances. This will allow you and your controller to get a list of all of the instances that actually have data associated with them, because we know if that process dies, it gets removed from the registry. And if that, like I said, if that process crashes, it gets removed. So at Optoro, we've used this same pattern to create an application that does just this for our worker instances. We call it Worker Tracker, and as you can see on the left, we have a whole bunch of instances that we're maintaining SSH connections to. On the right, we have what we're interested in, which is our active workers, and we also have terminate buttons there if we've deemed that those processes are problematic. But this is still this is still a reactionary type of situation. We have to notice that there's a problem here, and then we have to immediately take action on it. But it would be nice to kind of predict when we're going to have those issues. Maybe we could gather some information, establish patterns, and act on them before they become a real issue in our infrastructure. And in order to do that, we need metrics. At Optoro, we use Prometheus in our microservices architecture to scrape our instances and pull back metrics so that we can do just this. It'd be nice to bring those types of metrics to our metrics pipeline. And fortunately, there's already a library out there called Prometheus X, which does just this. We can add it to our Phoenix application. There's also integrations for Phoenix and Ecto themselves, so we can gather metrics on how our Phoenix application and our Ecto applications are working. So to do this, we would add Phoenix to our dependencies in our Phoenix application. As you can see here, I'm adding Prometheus, Prometheus X, Prometheus Phoenix. That will pull in our Phoenix instrumentation. We're pulling in Prometheus plugs. This contains a plug that will actually create our metrics endpoint for us so that Prometheus can scrape it. And we're also going to include Prometheus process collector to give us low-level process information about the instance that's running our Phoenix application. Additionally, we have to make sure that our Prometheus Phoenix and Prometheus X applications are started when our Phoenix application started. And then, at this point, we can create custom instrumentation. So here I've created a process instrumenter. We're going to use the Prometheus metric module. And this module expects you to create a setup function. And in that function, you declare your metrics that you want to use. Here we're declaring a gauge. We're going to name it instance process count. And we're going to give it some labels. We're going to give it a command alias in the instance that we pulled that command from. And we're going to provide a little help so that we know what this gauge is for. We're also going to provide a function that allows us to update this when the metrics change. So some additional thoughts when finalizing setup for Prometheus is that you have to add the plug exporter to the plugs in the Phoenix endpoint. Okay? And you have to add it before the router plug or the metrics endpoint won't show up. You have to call setup on all your implemented instrumentation in your application.ex start function. And you have to add your instrumenters to your config.ex file so that these started applications that I showed you in your mix.ex file or mix.exs file, they know where to find your instrumenters. And if all goes well, you can point Prometheus at your Phoenix app and you can start collecting those metrics. But we want prettier graphs. We want to be able to pull our metrics in. We want maybe to show them side by side with other metrics that we're creating so that we can establish patterns. And for that, we would need to use Grafana. Well, fortunately, Grafana already has a back end for Prometheus. So this is actually running on my laptop. I've got 10 SSH connections connected locally, and I've changed my Phoenix application to track the number of ZSH processes that I have running on my local laptop. The gaps in the metrics here show that when I've closed the lid of the laptop. But as you can see here, we are able to pull in the counts. So what I can do now is I can go to my terminal. I can create a couple more Z-shell processes. I can change the resolution here. As you can see here, we have more processes being reported. If you want to know what the metrics look like that are exposed by the Phoenix application, you can go to the metrics endpoint. And it's just a text format. And you can see here that I've got my ZSH command aliases and how many of them are running. Let me go ahead and refresh that. Okay. But you can also see that we're also exposing Phoenix information from our Phoenix application. We've got page view metrics, page controller metrics, and we also get channel metrics. So lessons learned during this project is that the GenServer call timeout defaults to 5 seconds. We're dealing with network connections, and network connections can be flaky. Sometimes there's a lot of latency in your network, depending on if you're on Wi-Fi or not. But this can be adjusted whenever you call GenServer.call. It takes a third parameter, which is the timeout, and you can adjust this if you want. You can even set it to infinity if you're brave. Also, dynamic supervisor max restart policy is 3 restarts within 5 seconds. So if you're having SSH connection issues and you're trying to start a data process to pull data from your SSH connection and it can't do that, it's going to crash. And if it crashes 3 times within 5 seconds, it's going to give up. And at that point, you probably need manual intervention. So in conclusion, I've shown you that with a contrived example, how you can monitor your infrastructure using SSH, Elixir, and OTP behaviors. I've also shown you that you can use these same OTP behaviors as a pattern, which can be applied to any Elixir project to bring concurrency and fault tolerance. The end. Are there any questions?
Hello.
Hello.
How would you go about testing something like this?
That's a good question. Testing can be tricky when you're dealing with SSH connections, and what I recommend there, XUnit provides an assertion to assert that you received a message. So you can go ahead and subscribe to your registry, and you can assert that you've received that message within your tests. You can also create a GenServer, a test GenServer module that basically follows the same, has the same functions that we defined in our SSH wrapper. And then you can use that to register with the registry and broadcast a connection ready event, basically. And then in that registry, you could provide, you could do pattern matching on an execute command, and then return generic process information that could be parsed by your data processes. And then you can assert that those processes have the right information. Anybody else?
Thanks for the talk.
Oh, thank you.
Great. Did you consider, or I guess, is there a reason, or would there be a reason to use multi-nodes and instead of SSH to have each node monitor itself and then communicate over the beam multi-node?
Right, yeah, so the secret here is that those applications aren't Elixir applications that we're monitoring. We're actually at Uptor, we're not using Elixir in production yet. Mm-hmm. Anybody else? Okay, I guess that's it. Thank you for being a great audience.